Yesterday you got to look at two different triangle congruency postulates, side, 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 and hypotenuse leg. What I want to do in this video is try to explain some things that I noticed. That way, hopefully you will get a better understanding of how these postulates work. So on this first one that I want to go over with you, let's look at side, side, side. On the two triangles at the top, I'll label them triangle A and triangle B. We can see in the picture that they both have a side that is listed as 17. They both have a side that has one tick mark, and they both have a side that has two tick marks. Therefore, they have three congruent sides. Okay, so therefore, triangle A is congruent to triangle B because of the side, side, side congruency postulate. Now, it's okay that we only have a tick mark and not a number. And what I mean by that is, let's say, for example, that maybe this side is 10 units long. Well, because the other side also because the other triangle B also has one side with a tick mark, we could assume that this side would also be 10 units long. Okay? And maybe the other side is going to be, I don't know, 8 units long, okay? Because triangle B also has a side with two tick marks, then it would also be 8 units long, okay? So all I'm telling you is that the tick marks show that the sides are the same, and that's how we can match up and see which ones work. So you could see numerical values. For example, I just wrote 8, 10, and 17 on those two top triangles, or like the bottom triangles, let's do that in purple. So let's say I could call this triangle X and triangle Y. I can say triangle X is congruent to triangle Y because both of those triangles have sides that correspond, and they're showing that they each have sides that are the same. Okay? Does that make sense? Now, what I do want you to notice is that the position is different. For example, I'm going to match up the sides that correspond to each other. This has two tick marks. This has two tick marks. This side has one tick mark. This side has one tick mark. And then this last side has 3 tick marks. And the last side over here has 3 tick marks. So if you can look at the triangles, they have different orientations. And actually, like, you could say that triangle Y was reflected and then rotated a little bit. That's okay. That still gives me congruent triangles. So triangle X is congruent to triangle Y by the side, side, side postulate. Okay, now let's look at an example with the hypotenuse leg. So with hypotenuse leg, that means that I have to have, when I'm looking at triangles, I have to have a congruent hypotenuse and a congruent leg, okay? Let's look at the triangles I'm going to label A and B. When I look at A and B, I don't see any numerical values in the picture. That means I don't see any side that's listed, for example, 7 inches, okay? I'm only looking at the tick marks. But these tick marks are enough to show me that they have a congruent hypotenuse, since it has 2 tick marks, and they have a congruent leg. That's enough for me to say that triangle A is congruent to triangle B using the hypotenuse leg. Okay? Now let's look at these other two triangles that I have. I'm going to label them as triangle X and triangle Y. If you notice in my picture, I can see that the hypotenuse on triangle X is congruent to the hypotenuse on triangle Y because they both have one tick mark. That means that I could also fill in more information in my picture. For example, I could say that this triangle has a hypotenuse of 13 since it matches up with the other 13. Now, I want you to really pay attention here. If you notice, on triangle X, I have a side length of 5. On triangle Y, in my picture, I have a side length of 12. Those are different numbers, but let's see if we can use a little bit more math to try and figure out, are these triangles congruent or not? Because remember, I need to have a hypotenuse and a leg that are congruent in order for me to say that these two triangles are congruent by the hypotenuse leg postulate. So if you remember this formula here that you see on your formula chart, this is the Pythagorean theorem. A squared plus b squared equals c squared, where c represents my hypotenuse. So if I were to plug this in on, let's look at triangle X, I could say I have a leg of 5. The other side I'm trying to solve for, but I do know that I have a hypotenuse of 13. So whenever I use this formula, I'm going to solve for b squared. So I have 169 minus 25 gives me 144. To solve for b, I want to take the square root. B has a value of 12. So notice that now whenever I did more further digging by using that Pythagorean theorem, I'm seeing that I do have a side length of 12, which matches up with my other triangle Y. That means that these two triangles are congruent to each other. So I could say triangle X is going to be congruent to triangle Y, and I know this because of the hypotenuse leg postulate. Okay, I hope that that was helpful and gave you more clarity with these two postulates.